Let's look at this graphic. What does it represent? All right, the title of the research is B12 deficiency, a hidden trigger of inflammation. But why? All right, we're looking at two factors here, C-reactive protein and interleukin-6. Now, if you notice down below, I drew some green arrows. The higher the B12 status in the individual, the lower these inflammatory markers were. So we're not even looking at B12 intake because the researchers recognize a lot of things, for example, like age, medication, so on and so forth, can influence B12 status. So instead of looking at B12 intake, they want to know exactly what the effect is on B12 levels in the individual itself and not in the diet per se. And what they discovered was the following. The higher the level of B12 status in the individual, the lower the likelihood of having these inflammation markers elevated, which is intriguing. For example, a long time ago, back in the 80s when I took nutrition, there was a big debate. For example, like in vitamin C. We knew the level of vitamin C required in order to mitigate susceptibility to scurvy. All right, albeit cool. But what if there were other deficiency states, for example, like susceptibility to exercise-induced asthma? And what level of vitamin C is required for that? So you never really knew exactly the optimal level. You knew how much vitamin C was required to prevent certain deficiency states. But what were all deficiency states? No one at that time really knew, and today they probably don't know either. But still, just the same, they want to interject publisher bias. So here we now have B12. We know B12 is basically a nutrient required to mitigate the susceptibility to a lot of neurological conditions. But how much is really required in order to have adequate control over these particular inflammatory markers? That is the question that needs to be answered in the future. Until then, let's delve into the research and determine how the researchers came to this conclusion and where it may lead to in the future to proceed as follows. Again, the green arrow, the higher level of B12 status, the lower, see the R, the lower, the basically these inflammatory markers, interleukin-6 and C-reactive protein to proceed. B12 deficiency, a hidden trigger of inflammation. Since chronic inflammation is associated with a wide range of diseases, understanding how vitamin B12 status influences inflammation can have significant implications for disease prevention and management. IL-6, interleukin-6, and C-reactive protein, CRP, are widely recognized as key markers of inflammation in clinical practice, as elevated levels of these markers are associated with various inflammatory conditions and chronic diseases. Establishing the relationship between inflammatory markers like interleukin-6 and C-reactive protein and vitamin B12 levels could have direct clinical relevance and open doors to novel therapeutic strategies. Quoting, of course. Quoting, our study found that in general, the more vitamin B12 an individual has, the lower the inflammatory markers are. We call this an inverse relationship. With regards to vitamin B12 deficiency, we must point out that we did not specifically look at deficient individuals in this study. Nevertheless, our results raise some important questions. We already know that vitamin B12 deficiency can be harmful in many ways, but what we have reported here is a novel relationship. This might help us better understand why some unexplained symptoms of vitamin B12 deficiency, like neurological defects, occur. An interesting side note to basically the researchers out there as well. This is a new discovery, at least as far as in the venue of this particular research. Surprisingly, the researchers noted that unlike humans, mice do not become B12 deficient with age. We didn't know this before. So this is real important stuff, and poses the possibility that studying mice could potentially help us understand how we can prevent B12 deficiency in older humans. So what the researchers are trying to imply here is maybe they can replicate or mimic that effect that mice have in not becoming B12 deficient with age in basically humans themselves. To proceed in the full study, this excerpt is from vitamin B12 or folic acid deficit leads to increased levels of homocysteine. Remember back in the year 2000, so trimethylglycine and things like that? Just as a recall, homocysteine is a sulfur-containing amino acid strongly associated with inflammation because it induces the production of pro-inflammatory molecules and reactive oxygen species, which you may see often referred to as ROS. This is particularly interesting because most common chronic and autoimmune diseases, including diabetes, cancer, atherosclerosis, and a closely related inflammatory process, are closely related to inflammatory process. Please forgive me. We hypothesized that serum vitamin B12 may be associated with lower concentrations of inflammatory biomarkers, interleukin-6, C-reactive protein. Therefore, the present study aimed to assess serum vitamin B12 levels and to evaluate the association, key word there, with the circulating inflammatory molecules interleukin-6 and C-reactive protein in a cross-sectional sub-analysis of participants in the PREDIMED trial. To the conclusion, the team now hopes to explore the link between vitamin B12 and inflammation within the context of specific high inflammation conditions such as infection, obesity, irritable bowel syndrome, IBS. Quote, we already know that vitamin B12 deficiency is not good for an individual and that dietary measures should be taken to correct it. It'll be interesting to understand if vitamin B12 supplementation can play a role in disease management, noted the researcher. So what an incredible, I would say, information to explore potentially with a medical practitioner. So for example, if an individual has unexplained inflammation and they don't know why, so they could deal with a medical practitioner, get the blood test, the serum B12 levels, potentially compare it to the graphs that we just saw in CRP and interleukin-6 and see if they are in an optimal range. That would be just beautiful because a lot of people do suffer from a lot of unknown or hidden pain, and they could be on antacids or medications interfering with B12 absorption or conversion, I should say, and just be simply mitigate the negative effects of whatever they're experiencing that's a result of inflammation due to just doing something simple, like maybe taking a form of methylcobalamin or hydroxycobalamin or whatever form of B12 that you have that's biologically available, that can help assist in making you feel, or a friend or someone else or a family member, feel so much better in such a eloquent, simple, and just basically genuine way. Again, gratitude to the researchers every week. You know, I hear I said that. I am humbled you watch, and I seriously mean that. And I can't wait to see what you and I share research-wise next week. Catch y'all next time. See you then. Bye.